somewhere in the Indian Ocean right now, moving at a depth and on a heading that will not appear in any public record, a Virginia-class nuclear attack submarine is on patrol. Its crew of 135 officers and enlisted cannot tell their families where they are. Their ship does not appear on any tracking system available to commercial maritime monitoring services. Its acoustic signature, when running at quiet speeds, falls below the ambient noise floor of the ocean itself. It cannot be found, and it is carrying 65 Tomahawk cruise missiles, 12 heavyweight Mark 48 torpedoes, and the sensor suite and weapon systems to find and destroy any submarine or surface ship that China, Russia, or any other adversary currently operates. The Virginia class is the most capable attack submarine ever built, not by a marginal amount, by a significant and, in certain dimensions, decisive margin. It is quieter than the Los Angeles class it replaced. It is more capable than the Seawolf class that briefly preceded it in production before Seawolf's cost made the program unsustainable. It is more versatile than any previous submarine in the history of the United States Navy. And it is being produced at a rate that is still not fast enough for the Navy's requirements at the two shipyards that are capable of building nuclear submarines: General Dynamics Electric Boat in Groton, Connecticut, and Huntington Ingalls. Industries Newport News Shipbuilding in Newport News, Virginia. No other shipyard in the world can build what these two yards build. No other nation builds anything that competes with what rolls out of these yards. This is the full story of the Virginia class, how it was designed, what it can do, why it matters more than any other platform in the Navy's inventory for the strategic competition with China, and why the industrial base that builds it is simultaneously the program's greatest asset and its most acute vulnerability. The Virginia class was conceived in the early 1990s as the Navy's response to the end of the Cold War and the beginning of a new strategic environment. The Seawolf class, designed to hunt Soviet ballistic missile submarines in the deep North Atlantic against the acoustic and tactical environment of the final Cold War period, was extraordinarily capable and extraordinarily expensive. Each Seawolf cost approximately $3 billion in 1990 dollars, a price that the post-Cold War defense budget could not sustain across the 50-plus boat program that had been originally envisioned. Seawolf production was terminated at 3 boats. The Navy needed something cheaper that could be built in larger numbers, that could perform the submarine's evolving mission in the post-Cold War environment where strikes on land targets and special operations support were becoming as important as anti-submarine warfare, and that could be designed from the beginning for the block upgrade approach that would allow it to improve continuously without requiring a new design for each generation of improvements. The Virginia class entered service in October 2004 with the commissioning of the lead ship, USS Virginia SSN 774, at Groton, Connecticut. The first Virginia-class hull was built on schedule, within the original baseline schedule threshold set 10 years earlier in 1994. For a major naval acquisition program, that was a remarkable achievement. The program had learned from the Seawolf experience and from the broader pattern of American defense acquisition programs that allowed requirement creep and schedule optimism to destroy the cost discipline that made programs affordable. The acoustic performance of the Virginia class is the characteristic that its designers are most proud of and that its adversaries are most concerned about. Every submarine is detectable if you know what acoustic signature to listen for, and if you have hydrophones sensitive enough to detect it at the ranges where detection is operationally meaningful. The question is not whether a submarine can be detected in principle, but whether it can be detected at ranges that give the detecting platform enough time to prosecute an attack before the submarine has completed its mission and departed. The Virginia class achieves acoustic performance that, at the quiet speeds it uses for most patrols, falls below the ambient noise floor of the ocean itself in many conditions. The ocean is not silent. It is filled with noise from shipping, from marine life, from geological activity, from wave action, from precipitation. A submarine that is quieter than those background sources cannot be identified against the noise floor by passive acoustic sensors operating at tactically relevant ranges. The Virginia class achieves this through a combination of design features that collectively eliminate the acoustic sources that made earlier submarines detectable. The propulsor, a pump jet rather than a conventional propeller, eliminates the cavitation noise that propellers produce at higher speeds, and that made earlier submarine classes detectable at significant ranges. The reactor plant is mounted on a raft system, an internal structure that isolates the machinery from the hull through vibration-damping mounts so that the mechanical vibrations of the operating plant are not transmitted through the hull to the surrounding water. The auxiliary machinery, the pumps and fans and motors that keep a submarine systems operating, are individually quieted and mounted to reduce their contribution to the ship's overall acoustic signature. The hull itself is coated with acoustic-absorbing material that reduces the reflection of active sonar pings. The result is a submarine whose acoustic detectability in passive sonar systems is, by the assessment of the Navy's own acoustic performance testing, significantly better than the Los Angeles class it replaced and competitive with any submarine currently operated by any potential adversary. The sensor capability that the Virginia class uses to find its own targets begins with the bow sonar, the AN/BQQ-10 system, the most capable submarine sonar system ever deployed. It integrates a large spherical array in the bow, a conformal array along the sides of the hull that provides broadband passive detection at frequencies the bow array cannot cover effectively, and a towed array that extends hundreds of feet behind the submarine and provides the long-range passive detection capability needed to locate submarines at the distances where engagement is possible before the adversary detects you. The combination of these three arrays, fused through digital signal processing and AI-assisted target classification software, gives the Virginia class an acoustic awareness of its environment that exceeds any previous submarine and that significantly exceeds the capability of most surface ships conducting anti-submarine warfare. The weapons that the Virginia class carries are matched to the sensor capability that can find targets to engage them against. The Mark 48 ADCAP torpedo, the heavyweight wire-guided weapon that sank the Iris Dana in the Indian Ocean in early 2026, is the most capable anti-submarine and anti-ship torpedo in the world. It is wire-guided from the submarine to its target, allowing the crew to steer it around countermeasures and obstacles, and it carries a high-explosive warhead designed to detonate beneath the keel of its target, exploiting the water hammer effect to break the target's structure rather than merely penetrating its hull. A single Mark 48 fired accurately will sink any submarine or surface ship that it is designed to engage. The kill of the Iris Dana, 40 nautical miles south of Galle, Sri Lanka, was precisely this scenario. One torpedo, one frigate. The frigate broke and sank. The Block 5 Virginia class adds the Virginia Payload Module, which transforms the submarine from a capable but limited land attack platform to a genuine long-range strike asset capable of replacing the 4 Ohio-class SSGNs as they reach the end of their service lives and are decommissioned. The VPM is an 84-foot hull extension inserted between the forward and aft sections of the submarine's pressure hull that contains 4 large-diameter vertical launch tubes. Each tube holds 7 Tomahawk cruise missiles. 4 tubes times 7 missiles is 28 additional Tomahawks, added to the 12 that the Virginia-class boat tubes can accommodate, for a total of 40 Tomahawk missiles per Block 5 boat. The Block 5 extends to 460 feet and displaces 10,200 tons submerged, compared to 377 feet and 7,800 tons for the earlier blocks. The Block 6 Virginia class, for which funding was initiated in fiscal year 2025, with the first 3 boats named USS Potomac, USS Norfolk, and USS Brooklyn, adds the conventional prompt strike hypersonic missile capability that gives the submarine the ability to strike targets anywhere within its operational area, with a hypersonic weapon capable of speeds exceeding Mach 5. The Block 6 will also incorporate fiber-optic connected drones that can be deployed from the submarine while submerged, connected by a strong cable, and interface with military communications networks, allowing the submarine to share data from its sensors with air, surface, and land communications nodes without surfacing. A submarine that can extend its sensor reach through a deployed drone while remaining deep and undetected represents a capability that has no precedent in naval warfare. The production challenges that the Virginia-class program faces are as significant as the capabilities that the program is delivering. The two shipyards that build Virginia-class submarines, Electric Boat and Newport News, were contracted to produce 2 boats per year beginning with fiscal year 2011. The actual production rate has never reached 2 boats per year. Since 2022, it has averaged approximately 1.1 to 1.2 boats per year, well below the contracted rate and below the minimum needed to prevent the attack submarine force from declining below the Navy's stated requirement for 66 Virginia-class boats by 2043. The drivers of the production shortfall are workforce, supply chain, and infrastructure. Electric Boat and Newport News collectively employ tens of thousands of skilled workers. Nuclear submarine construction requires skills that take years to develop and that cannot be rapidly acquired from other industries. A welder who builds nuclear submarine pressure hulls must meet certification standards that take years of training and qualification to achieve. When the workforce is insufficient, hulls sit partially complete while the shipyard waits for qualified workers to advance their construction. Post-COVID workforce disruptions hit both yards severely, and recovery has been slower than the program's requirements demand. The supply chain for Virginia-class construction involves hundreds of specialized suppliers whose products meet the quality and reliability standards that nuclear submarine construction demands. A single supplier's inability to deliver a specific component on schedule can delay the entire hull's construction by weeks or months. Nuclear-grade valves, pumps, heat exchangers, and electronic components are not interchangeable with commercial equivalents. They are purpose-built to specifications that only a limited number of suppliers can meet. When those suppliers face their own workforce and materials challenges, the downstream effect on submarine production is magnified by the already constrained production capacity at the yards. The AUKUS commitment has added an additional dimension of pressure to an already strained industrial base. The September 2021 AUKUS agreement between the United States, the United Kingdom, and Australia, which includes the transfer of Virginia-class submarines to Australia as part of Pillar 1, requires the American submarine industrial base to sustain production at rates that supply both the U.S. Navy's requirements and the Australian commitment. The Navy has testified that it plans to sell 3 to 5 Virginia-class submarines to Australia under the AUKUS framework. The submarines to be transferred cannot simply be additional production. They require the industrial base to produce at a higher rate than it is currently achieving. The $987 million contract modification awarded to Electric Boat in June 2025 for submarine industrial base supplier enhancements and the $12.4 billion contract covering SSN 812 and SSN 813 awarded in May 2025 are investments in the industrial base capacity needed to eventually achieve the 1+2 production rate, 1 Columbia-class and 2 Virginia-class submarines per year that the combined Navy and AUKUS requirements demand. The target for achieving that rate is 2028. The competition with China's submarine force gives urgency to every production shortfall, every delivery delay, and every workforce shortage that affects the Virginia-class program. China's People's Liberation Army Navy has been expanding its submarine fleet at a rate that American naval analysts describe as the most rapid submarine buildup since the Cold War-era Soviet program. China currently operates approximately 6 Jin-class nuclear ballistic missile submarines, 12 Shang-class nuclear attack submarines, and approximately 50 diesel-electric submarines of several classes. The quality gap between American and Chinese submarine technology remains substantial. Chinese submarines are assessed as significantly louder than Virginia-class boats, with acoustic signatures that American passive sonar can detect at ranges that allow engagement well before the Chinese submarine has a tactical solution against an American target. The Type 093B Shang class, the most capable Chinese nuclear attack submarine currently operating, is assessed as comparable in some acoustic dimensions to the Soviet submarines of the 1980s that the Los Angeles class was designed to defeat. But the quality gap is narrowing, and the quantity is already formidable. China is building submarines faster than its technological advances can keep pace with. The Type 095, China's next-generation nuclear attack submarine, is expected to represent a significant improvement in acoustic performance over the Shang class, potentially approaching the quieter end of the Los Angeles class performance range. When Type 095 enters service in numbers, the acoustic advantage that the Virginia class enjoys over Chinese submarines will be reduced, not eliminated, but reduced. The Navy's response to this trajectory is to continue improving the Virginia class through the Block 6 and beyond, while investing in the undersea systems that can extend American advantage in the domain that matters most: acoustic detection and engagement at ranges and speeds that deny the adversary a tactical solution before it is too late. The Virginia class is not just a submarine. It is the centerpiece of American undersea dominance, the instrument through which the Navy maintains the ability to deny adversaries free use of the ocean and to project power from the sea in ways that surface ships cannot match in contested environments. Its acoustic superiority is its primary strategic asset. Its weapons payload, expanded through the Virginia Payload Module and soon through hypersonic missiles, is its primary operational contribution. Its production rate, currently below requirements, is its primary vulnerability. The Chinese submarines cannot find it. The Iranian frigates could not hear it coming. The torpedo that sank the Iris Dena in the Indian Ocean announced itself to the crew of that ship only in the seconds before impact, when it was already too late. That is the Virginia class performing exactly the function it was designed to perform. If you want to understand how the Navy plans to maintain undersea superiority against China's improving submarine force through the 2030s and beyond, how the AUKUS submarine transfer will affect American SSN force levels, and what the Block 6 and SSNX next-generation submarine programs represent for the long-term trajectory of American undersea power, subscribe to Navy Power Decoded. Every video is built on the analysis that the threat environment demands. It owns every ocean it sails in, for now. The production math that underlies the Virginia-class program is worth examining in detail because it reveals the structural tension between what the Navy needs and what the industrial base can currently provide. The Congressional Research Service, analyzing the program's production history and projections, identified a fundamental problem. The Navy requires a minimum of approximately 66 attack submarines to meet its force structure goals across all mission areas. Achieving that goal requires producing Virginia-class boats at the rate of 2 per year while simultaneously sustaining the Columbia-class ballistic missile submarine program, which requires 1 boat per year. The combined production requirement is 3 nuclear submarines per year. The actual production rate across both programs in recent years has been approximately 1.1 Virginia-class boats per year, well below the rate needed to prevent the attack submarine force from declining below the 66-boat threshold. The decline is already measurable, As Los Angeles-class submarines reach the end of their service lives and are decommissioned, and as Virginia-class production fails to keep pace with the retirements, the total attack submarine force is projected to fall below 50 boats in the mid-2020s, a level that the Navy's own analysis identifies as insufficient for the global missions assigned to the submarine force. The gap between 50 boats and 66 boats is the gap between a submarine force that can meet its assigned commitments and one that must make difficult choices about which commitments to honor. The AUKUS submarine sale adds another dimension of pressure. Selling 3 to 5 Virginia-class submarines to Australia requires either producing them in addition to the Navy's own requirements, which demands a higher production rate than is currently achievable, or transferring hulls from the American fleet, which reduces the American force below what it would otherwise be during the transfer period. The Navy has testified that it intends to manage the AUKUS transfer through additional production rather than fleet drawdown, which means achieving the 1+2 production rate by 2028 is not optional. It is the minimum required to honor both American force structure requirements and the AUKUS commitment simultaneously. General Dynamics Electric Boat has received over $1 billion in industrial base investment specifically to increase its workforce, improve its production processes, and remove the supplier bottlenecks that have limited delivery rates. The $987 million contract modification in June 2025 and the $12.4 billion multi-boat contract of May 2025 are the most visible elements of a sustained investment program designed to produce the industrial capacity the program requires. BAE Systems received a $70 million contract from Electric Boat to manufacture Virginia Payload Module missile tubes for Block 6 boats. Newport News has been investing in its own production infrastructure. These investments are real, they are substantial, and they are necessary. Whether they will be sufficient to achieve the 1+2 production rate by 2028, the target the Navy has set for itself, will be determined by workforce development and supplier performance over the next 3 years. The Virginia class will remain the centerpiece of American undersea power through the 2040s. The follow-on SSN-X program, the next-generation attack submarine intended to follow the Virginia class in production, was originally planned for procurement beginning in 2025, but has been pushed back to 2033 or 2034, with an extended development timeline reflecting the technological ambitions of a system designed to operate in the threat environment of the 2050s and beyond. For at least the next decade, the Virginia class in its Block 5 and Block 6 configurations is the American undersea advantage. Everything the Navy plans for the Pacific competition, every scenario in which submarines play a role, is built around the assumption that Virginia-class boats will be available in sufficient numbers and at sufficient readiness levels to execute those plans. The submarine that sank the Iris Dena in Indian Ocean waters with a single Mark 48 torpedo proved something that strategic analysts already knew, but that the watching world needed to see demonstrated. An adversary cannot find a Virginia-class submarine. An adversary cannot hear it coming. An adversary cannot defend against it effectively because by the time the weapon is in the water, the decision has been made, the solution has been computed, and the outcome is determined. The submarine that changes everything is the submarine you never knew was there. In the Pacific right now, Virginia-class submarines are there. China knows they are there in general terms. China cannot find them specifically. That asymmetry is the foundation of American undersea dominance. It is measured not in ship counts, but in the acoustic physics of a submarine quieter than the ocean itself.